Hey guys. Unreal Engine, as you probably know, has a built-in garbage collection system that can be used for UObjects and their properties in your game in order to free them when you're done using them. There's a few caveats with it though, and so this tutorial is going to explain how to use the garbage collection system and answer a lot of those questions you may have after using it. So what I want to start with is I have a player controller here as usual, and I went ahead and created some test classes that we're going to be using in order to demonstrate the different aspects of UProperties and garbage collection. So we just have a class that doesn't inherit from anything. It's just a non-UObject. We have just some object here that does inherit from UObject. We've got a struct that has a USOmObject pointer. And we have a test interface. And this is how you define interfaces in Unreal if you're unfamiliar with the syntax. And then lastly, we have an object that inherits the interface. And the destructor of all the objects here is overridden, and if you go to the CPP here, all that does is print out when things are created and when things are destroyed, so that we can look in the logs later when we launch the editor, and we'll be able to tell when garbage collection has destroyed our objects. So to get started, let's just start with the basic UProperty marker. So in order to make the garbage collection system aware of your object, let's say that we have a member variable here, and we'll just use our USOmObject class that we just looked at. So we have USOmObject, SOMObject equals null pointer. So right now, if I use this, let's say I go to the CPP and I say SOMObject equals new object, USOmObject. So at the moment, the garbage collection system doesn't know about this, and so it doesn't know that it can be freed. So if we go to the header and we type UProperty, UProperty now marks this object so that the garbage collector knows about it, among other things that being a UProperty can do. So now SOMObject will not be released as long as a test player controller is there. So we can go ahead and build and run this now. And for all the examples in this tutorial, I'm going to start by clearing the console and turning on garbage collect every frame. If you're unfamiliar with this command, it's really helpful, but you can do collect garbage every frame and set it to 1 for on. And now you can see in the log, it's just going to constantly garbage collect. So now when I start, we just have a test level here that uses that same player controller we just modified. If I hit play, we can look at the logs and we can see our USOmObject got created, and it will never get released because it's a UProperty on the player controller, which is still there. But you notice when I stop the level, we get subobject destroyed, because once the player controller goes away, now it's safe to free that object because there's no more references to it. So that's all pretty simple. So let's close this. And now, if we were to clear this pointer right away, just after creating it, this object will still exist, but now there won't be anything referencing to it. So if we build again, and once again, if we turn on garbage collect every frame, and I start, so now you'll see our object got created as it did before, but because I cleared the reference immediately after, there's nothing referencing it anymore, and so the garbage collector destroyed it almost right away. So that's behaving as we would expect. So now there's a few caveats with this system that I want to talk about. If we close the editor, you'll notice usually when you create an object, you'll give it a parent. Let's say this. So this object is now parented to the player controller. So if I were to run and test this, this would behave the same as it did before. This object would stick around until the player controller goes away, and then everything will get cleaned up. However, if we want to use this pointer somewhere else, so let's say that on our game instance, we're going to switch levels and we want to keep this around for the next level as well. I actually have that set up here. So if I go to tutorial game instance, notice this also has a UProperty called SOMObject. And so back on our player controller, what we can do is get a reference to that game instance. And I can say tutorial game instance equal game instance equals get game instance. And then I can say game instance SomeObject equals SomeObject. So now we're storing that same property on our game instance, and at this moment there would be two references to this. But now let's see what happens when I actually go to another level. So I'm going to say U gameplay statics, open level, game instance, and I have another level called other map. So we'll just travel to there. Now, this travel is going to get rid of our player controller, and so this reference that is a U property is going to go away. But initially you'd expect that we still have a reference here, and so the object shouldn't get cleaned up because there's still something using it. So let's see what happens. And so now, if I play, it's going to immediately switch to their level after creating those objects. And let me turn on garbage collect every frame. But what you'll notice is, right when the level started, some object was created, but then when we switched levels, you'll notice that the object got destroyed, which is odd because the game instance still has a reference to it. And so if you were to use that reference now, it would crash, and you'll actually notice that the UObject system would actually set that pointer to null on the game instance as well. So what happened here? Well, when you switch levels, there is actually a way for objects to get cleaned up, even if there's still references to them, and that's because of this outer here. So when you specify the outer for a class, that doesn't directly participate in the garbage collection process. However, when some other things happen, such as switching levels, every object the level owns is cleaned up, and it goes through the ownership graph based on these outer pointers here. So when you have a pointer back to the player controller has a pointer back to the level as well. And so anything associated with the player controller is via the outer pointers is going to get cleaned up, even if there are still references to it. So you might say, well, okay, that's fine. I'm going to add it to the root set. And if you're unfamiliar with AddToRoot, there's a way, the way garbage collection works is you start at all of the root objects and you explore down that tree of all their references and, through their U properties and through their collections and so on. And any object that is in the root doesn't need references pointing to it because it's in the root set. It's not going to get garbage collected. So you might think that we can say SomeObject AddToRoot, and that would do it. But let's try that. And once again, we're just going to turn on garbage collect every frame. And start. And now you can see we actually get a crash. And the reason is, if I go back to our tutorial project in player controller, now that it's in the root, when we switch levels, and the level goes through and tries to clean up all the objects, it actually checks to see if any of the objects that you're cleaning up are in the root set. And now they are, and it's trying to delete it, and so this is an error. So what we really want to do is we don't want this object to be owned by the level at all. And so if I stop our execution here, I can remove this AddToRoot call and instead take away this outer here. And now if we run and do the same thing, and if we run like we did before, so if I scroll up, you can see that some object was created, but now when I scroll down, you see it's never freed. And that's because it is no longer parented to the player controller, so it is no longer part of the level, and so the level doesn't clean it up when it explores its object graph. And so that is something you got to be careful of with this. So this is a pretty common use case where you want to store stuff on the game instance so that it doesn't get cleaned up between level switches. And so if you're going to do that, make sure that the outer is not set to something within the level. Now you could actually put the game instance here as well. If I get the game instance a little bit earlier instead, now I can put game instance as the outer. And if I test this, and when I hit go, you can see, just like before, if I scroll up, the object gets created here, And if I scroll down, you can see it never gets freed. So this works as well. But yeah, just make sure that your objects aren't parented to things in the level when you switch levels if you want them to stick around. So you might also wonder if the garbage collection system can collect non-UObjects, and it cannot. So if I go back to that test classes thing, you can see I have non-UObject defined here, which is not a UObject. That Unreal does not know about it. And so if I were in player controller and I make an instance of this, and I'll call it some non-UObject, you'll notice if I make this a property and I try to build, if we look at the output that we get, it's going to give us an error from UHT, Unreal Header Tool, and it says unable to find class with name non-UObject. And this is just because we didn't mark it as a UClass or a USTRUCT, and so it doesn't know about it. So you can't garbage collect non-UObjects. However, you could make this a shared pointer instead, and you could get ref counting that way as an alternative way of doing memory management if you wanted to. So the next thing I want to talk about is collections. So one other maybe not obvious thing that Unreal Engine does is if you have a UProperty to one of Unreal's collections, it won't, or it'll add a reference to each one of the objects in those collections as well. So if we have a TArray, for example, of USOmObject pointers, and by default, let's remove this old one. By default, if you were to add UObjects to this, they would not be referenced. However, if we make it a UProperty, like so, and then we add a bunch of UObject pointers to this, they will not be garbage collected. And so if I go to our player controller and I delete all this stuff, I could say some array, and actually I have to include that somewhere. So if I come up here and I type include containers/array, and actually I should do that in the header file since I use it here as well. But in any case, if I do sumarray.add, I can do new object, USOmObject, and we can do that a few times. And you can see if I build and run this. So now if I start, we can see that those three objects will be created. If I look at the logs, 3 USOmObjects, and we have a reference to them, so they won't be removed until we stop. And then you can see they're removed because the level was stopped. But if I now remove these all from the array, so add 3 objects, and then I do sumarray.empty, and I build and run that. So now if I start, you can see the 3 objects are created right away, and because I cleared the array and thus removed the reference that is accessible through the UProperty, all 3 are destroyed right away. So you can see the garbage collector works on arrays as well. So one other question that I've seen is, can you have a UProperty from within a struct? And if you do that, does the garbage collector know about it? So let me remove my array real quick and show you what I mean. If I go to testclasses.h here, you can see I have a structure defined, fSumStruct, and it has one property, SumObject, and it's marked as a UProperty. So the question is, if I have SumStruct on my player controller and I assign SumObject, will that get garbage collected? In other words, will the garbage collector be able to follow the reference through an fSumStruct? So let's try that. If I go to player controller, I can do fSumStruct, SumStruct, and notice this isn't a pointer, this is just a member of the class. And I can make it a UProperty. And now if I go to player controller, I can say SumStruct.SumClass equals new object, or sorry, new object. So SumStruct.SumObject equals new object, USOmObject. And so the question now is, will SumObject get cleaned up? if I start, so now if I run this, see our object once again gets created and does not get freed. And if I restart and I clear this reference on our struct, so SumStruct.SumObject equals null pointer, and we go again. Now if we run again, so we've cleared the pointer this time, so you can see the struct gets created, and then because now there's no reference to it, the SumObject gets destroyed. And so you can have UObjects within structures, as long as they are marked UProperty. One last thing I wanted to cover is interfaces. So let's say that you had an interface pointer to a type, but it's not the actual type of the object. So in the test classes header here, as an example, we've got iTestInterface, and we have UObject with interface that implements this test interface, and all that's on it is this test method. And we have UInterface on the UTestInterface object so that Unreal knows about it as well. And this is just how you declare an interface in Unreal. It's all standard. So if I go to test player controller, let's say that I have iTestInterface SumObject equals null pointer. And in test player controller, I do SumObject equals new object. And the underlying type will be UObject with interface. And so this iTestInterface pointer, SumObject, will have a new UObject with interface. So if I go to make this a UProperty now, you'll notice just like with the class that wasn't a UObject earlier, if I try to build this, the Unreal header tool is going to yell at me and say, hey, I don't know what this class is. So say UProperty pointers cannot be interfaces. Did you mean to add TScriptInterface? And so this is actually the right suggestion. If we want to do this, we can. We can say TScriptInterface, iTestInterface SumObject. And we can use it the same way. We can say SumObject equals new object, UObject with interface. And so this will actually work if I build and run this. And likewise, if I run, you can see our object gets created. And because that UProperty test interface is holding on to it, it will never get freed. And just to emphasize that point, if I close this and I remove our UProperty from the header, and so now it won't have a reference, and I build that again, you can see now if I run, we create our object, but now it gets destroyed right away because the interface property was actually holding on to a reference when it was marked UProperty. So if you want an interface to hold a reference to an object, that's how you do it. Use this TScriptInterface wrapper and mark it UProperty, just like you would for if you had a direct pointer to the class here, as usual. So one caveat with this is we already went over how you can use like TArray as a collection, and if you make the TArray a UProperty, then it will add a reference to all of its sub-objects or all the objects that are added to it. So let's say that you had TArray here of iTestInterface, test interface pointers rather, and we're going to call it array of interfaces. So the compiler will actually let you do this, and so let's add some objects to this. So instead of SumObject equals, we're going to do array of interfaces.add, and just add a few of those. So now we're adding the underlying object of type UObject with interface, which is an iTestInterface, or implements that interface. And we're specifying UProperty, and this is a TArray, so this should add references to all these, right? So let's go ahead and build that. And what you'll notice if I run this now is we actually get a crash that says invalid object in garbage collection. And the reason for that is that if we go back to our player controller, this actually isn't valid, even though UHT allows it. This actually might be a bug in UHT, to be honest. It should probably be able to flag this, but it doesn't. An iTestInterface isn't a UObject, and it's not a TScriptInterface, and so this isn't valid. So if we wanted to fix this error, we just do the same thing we did before that UHT did warn us about, and we can say it's TScriptInterface instead. And so if we were to add that wrapper, and now I build this again. And so now if we run, you can see it works just fine. It creates all three of our objects, adds them to the array under the interface, and it's still a U property, and so they don't get freed. And so if you do end up with that crash because you have an array of interfaces that's a U property, this is how you fix it. Use TScriptInterface instead of just a raw pointer to the interface, and it should work just fine. And so just to summarize everything, in order to make sure something has a garbage collector reference so it doesn't get cleaned up when it shouldn't, you can mark it U property, and this works with UObjects. It works if you have a structure that has a UObject in it, as long as both are marked U property. If you want something like a singleton to always exist even if it has no references, you can add it to the root set using AddToRoot. If you want something to survive across levels, you need to make sure that the outer object, when you use new object, is not something that's tied to the level like the player controller. So tie it to something like the game instance or don't have an outer. And if you want to use interfaces, you need to use the TScriptInterface wrapper if you want to make them U properties, and other than that, they behave the same way. So thanks for watching, everybody. If you liked the video, hit like down below, and if you like the content and want to get notifications for future videos, please feel free to subscribe. So thanks again, and have a good one.